Bismillahirrahmanirrahim. In this video, I'll proceed with the counting rules. Let's recall what we have learned in the previous video. There are three rules can be used to determine the number of all possible outcomes for a sequence of events. So we have discussed the first method, which is by using fundamental counting rules. So in this video, we will discuss permutation and combination. Let's look at the difference between permutation and combination. Let's say we have 4 letters here and we want to use 2 out of 4. Permutation is when the orders is a method. AB and BA is considered two different outcomes. We have CA, AC and another two different outcome. Same goes to the DA and AD, BC, CB, DB, BD, CD and DC. So the total number of arrangement, we have 12 total number of arrangement for the permutation. Combination when the orders does not matter. For example, we want to use 2 letters out of 4 here. AB is equals to the BA. When you have A and B in that combination, it is considered only one possible outcome. Same goes to the BC equals to the CB, AC equals to CA, BD equals to DB, and so on. So the total number of possible outcome, it is equivalent to 6. Or by using the formula, you can use your calculator. It is equivalent to, we have 4. So 4C2, so you will get 6. If you use permutation, it is equivalent to 4P2. So you will get the total number of outcome is 12. Let's look at to the example 4. There are 7 contestants in a Sudoku contest. How many possible ways are there for the first 3 places to be won by the contestant? So since we want to find out the winner, so the arrangement is important. Normally when we have the question like this, you have to always ask yourself whether the arrangement is important or not. For example, this one, we want to find out the winner. Of course, the first, second, and the third place must be important and the others is a method. Therefore, we will use permutation. Out of 7 contestants, you want to have 3 winners. So 7P3 is equivalent to 210. Now let's look at to the example 5. In how many ways can a president, vice president, and a secretary be chosen from a 20 females and 30 males? So since we have a specific position here, therefore the arrangement is important. Total number of students we have 50 for you to choose 3 position or 3 posts. So 50 P3, 117, 600. Let's look at to the next example. In how many different 4 letters word can be formed from the letters in the word mineral? So since we have MINERAL, they are 7 letters. And it is important, let's say you have M, I, and E, the same letters, the same 4 letters, and the arrangement as I, M, E, N, it is considered 2 different outcomes. Therefore, in this case, the arrangement is important. By using permutation, 7P4, then we will get 840. Let's proceed with the example 7. 3 boys and 4 girls are to be seated in a row of 5 chairs. Find the number of ways they can be seated if the first and the last chairs are for the girls. So we have 1, 2, 3, 4, 5. 4 girls for you to choose in the first chair, and the second chair there is remaining 3 girls. So it will become 4, 3. And for the middle chairs, it doesn't matter whether it is a boy or a girl. So we start with the remaining girls, which is 2 girls, plus with the 3 boys. So total remaining people here, we have 5. So therefore 5. And then for the next chairs, 4. And the next chairs is 3. So the total number of ways, we have to multiply everything. So it is equivalent to 720. This is by using multiplication principle. Since the arrangement is important, you can also use permutation. So by using permutation, we want to arrange first two girls for the first and the last chair. So therefore will become 4p2 and remaining 5 people for you to arrange in the 3 remaining chairs. So 5p3, you still get the same answer, 720. Okay, let's look at to this one. When we have more than one case, what we have to do, in the previous example, we have only one case. Given a set of items, it is possible to form multiple groups by ordering any one item from the set, any two items from the set, and etc. If we want to find out the total number of arrangements from the multiple group, we have to add the result of each case. Let's look at the examples here. How many different signals can be made by using at least 3 distinct lights if there are 5 different lights from which to select? So we have at least 3. So meaning that must have 3, the lowest. It can be also 4 light used, and we can also have 5 lights used. So for the 3 light will become 5p3. So why we have to use permutation? Because when you use different light, it will give you different signal. And we need to add for the second case, which is 5p4. And for the last case, by using 5 light, you have to add another one, which is 5p5. So the total number of ways is 300. Now let's proceed with the example 9. How many one letter, two letter, three letters word can be formed from the word source? So we have for the one letter, total number of letters is 6. So 6p1 plus 6p2 and plus with the 6p3. So the total number of ways is 156. Example 10. A committee of 5 members are to be chosen from 15 candidates. In how many ways can the committee be formed? So since you want to choose just a committee without any specific post, so we have to use combination because arrangement is not important. Let's say you have Ali, Amina. So between another one, we have Azhar. So you want to choose two of them to be a committee. It doesn't matter whether you choose Ali first or Amina first. You can also choose Amina, Ali. As long as two same people, it is considered only one outcome. Therefore, by using combination, 15C5 is equivalent to 3003. Now let's proceed with the combination including specific item. A school committee of 5 is to be formed out of 12 students. How many committee can be formed if Fatima is not be on the committee? So since we have Fatima to be chosen and Fatima is included in that 5 committee, therefore we have remaining 11 people for you to choose another 4 committees. So the arrangement is not important because we want to choose a committee. So we have 11C4. So for this one, if you doesn't put here is also can, you can just write down as 11C4. So it's equivalent to 330. Now let's look at to the next one, combination from multiple selection. A student has to answer 5 questions, choosing 3 questions from part A, 2 questions from the part B. If there are 6 total questions in the part A, 5 questions in the part B, how many ways can the student choose 5 questions? From the part A, we have 6 questions for the student to choose only 3, and for the part B there are total 5 questions to choose only 2. So the total number of ways we have to multiply, so we will get the total number of ways is 200. So it mentions here, when presented with the multiple groups of items from which to choose, you must multiply the individual cases together. This one is still considered one case, it's not different case. Therefore, we will multiply. Then we move to the at least and at most case. When we have at least and at most case, what we have to do, we have to add all the possible cases together. A research team of the 6 people is to be formed from the 5 chemists, 3 politicians, 4 economists, and 6 biologists. How many teams are possible if at least 2 biologists to be included? Okay, we have several cases here. First, you need to consider one by one. So this is the condition, at least 2 biologists. Let's say we calculate for the 2 biologists, the minimum. So 2 biologists meaning that we must have 6 people in the committee, and we have 6 biologists. For the 2 biologists to be chosen, 6 C2, and then for the remaining 4, since 2 biologists and we must have 6 people, we have remaining 4 people to be chosen from 5 chemists, 3 politicians, and 4 economists. So total between these 3 is equivalent to 12. So 12 C4. So this is for the first case. For the second case, you might have 3 biologists. So for you to choose 3 biologists, so 6C3 times with the, we have remaining 12 for you to choose another 3 people. Then the next one, 4 biologists, 6C4 times with the 12C2. Then the next one, we have 5 biologists, goes to 6C5 times with the 12C1. And the last one, we might have all the biologists in a team. So for the all biologists, we just put it as 6C6. So the total number of ways we need to add all together. So when you add up everything, so you will get 12888. Okay, let's look at to the next one. There are 7 women and 5 men in a department. In how many ways can a committee of 4 be selected if there is no condition? So when there is no condition, we have 7 women and 5 men. So total women and men, we have 12. No condition, we can choose anyone, any 4 of them. So 12C4, so 495. Then for the part B, we have condition 2 men, 2 women. And we must have 4 people. Therefore, 7C2 times with the 5C2 is equivalent to 210. Why we have to multiply? Because it is still the same case. We need to have 4 people. So 7C2 for you to choose from women, and 5C2 for you to choose among men. And then for the part C, we have at least 2 women on the committee. So 7C2 for you to have 2 women, and the remaining is 5C2 for the men. And then since at least 2 women, we might also have 3 women. Then times with the 5C1 for the remaining men. And then we might also have all women be selected. So 7C4. So the total number of ways is equivalent to 420 by considering all these cases. We have 1, 2, 3 cases. For the last question, we must have at most 3 women in the committee. So you might have no woman, 0 woman, meaning that all people be chosen must be from men. So it must be for men. And then if you have only 1 woman, so you must have 3 men. If you have 2 women, you must have 2 men. And at most 3 women, of course, you must have only a man. Therefore, by considering all these 4 cases, we have here 7C0 times with the 5C4 for the first case, plus with the second case 7C1 times with the 5C3, plus with the third case we have 7C2 times with the 5C2, and the last case with the 3 women, 7C3 times with the 5C1. So the total number of ways should be 460. Now let's look at to the next one. A committee of 7 consists of a chairman, a vice chairman, a secretary, and 4 other members to be chosen from a class of 20 students. In how many ways can a committee be chosen? So we have total 20 people for you to choose the first 3 specific position, and for the remaining, since we already have 3, we must have remaining 17 people to be a committee. Therefore, for the committee, we have 17C4. So the total number of ways 16279 200. Now let's look at to the last example here. Given the digit 1, 2, 3, 4, 5, and 6, how many 3 digits number can be formed if the digits are not repeated? So we want to have 3 digits and we have 6 digits given. So for the first digit, since the digit cannot be repeated, so there is 6 option and you cannot repeat, you have remaining 5 digit to be selected, and the last one we have 4 digit to be selected. So the number of possible digit is 5 times 5, 6 times 5 times 4. So they are 120 possible numbers to be formed from the 3 digits when the digits are not repeated. And then for the part B, the numbers are divisible by 5 and the digits are not repeated. So we still want to form numbers with the 3 digit, and when it is divisible by 5, it is determined by the last digit. It's either 0 or you must have 5. So since there is no option for the digit 0, so the possible digit you might have is only 5. So we must have only digit 5. Therefore, there is only one way for you to have a digit 5 in the last digit of the 3 digits number. And then since the digit cannot be repeated, so you have remaining 5 digit to be selected for the first digit. For the second digit, you have remaining 4 digit. So the total number of outcome is equivalent to 20 possible 3 digits number. And then for the part C, the number is less than 300 and the digits are not repeated. So we have 3 digit. Less than 200 is determined by the first digit. So we have is either the first digit can be either 1 or 2. So since you have only 2 options, so you can use as 2 or you can just put as a 2P1. And then for the next digit, you have 5 options because you cannot repeat the digit of 1 or 2 or the digit that you already choose in the first digit. And then the next one, you have remaining 4 options. So therefore, the total number of ways is equivalent to 40. And then the last one, the digits are even and the digits can be repeated. It's either the number is even or odd. It is determined by the last digit. So we must have even number as well. So 2, 4, or 6. So there are 3 options, or you can put it as 3P1. And since you can repeat the digit, therefore you have another 6 option for the first digit and 6 option for the second digit. So the total number of ways is equivalent to 108. Okay, that's all for this video. So you can try out the exercise from the 2.1. Thank you.